Hello and welcome to this video about change of percent. The learning target for this video is being able to find, apply, and solve with change of percent. Now, first things first, let's talk about what it is. So change of percent is a way to measure increase or decrease, this is the key word here, relative to itself. And this is kind of an important measurement. And let me give you this example right here. Let's say we had two schools, all right? We have school A and we have school B. Now, both these schools from one year to another lost 300 students for whatever reason. Now, you might be thinking that, they both lost 300 students, so they both lost the same amount. But what if I told you that school A had a population of 1,000 students before they lost their 300 students? And school B is a big university that has 15,000 students. As you can see, school A is impacted a lot more. And that's because a larger percentage of its population was lost. Whereas here in school B, not impacted as much because they have a lot of students. So losing 300 doesn't seem like that big of a deal. But 300 out of a school of 1,000, that's getting awfully close to losing, half your student population. And so again, that's what change of percent is. It's about measuring the increase or decrease relative to itself. We're wondering, how much bigger or smaller did something become? Now, let's get to the details about it. Let's talk about how do we find it. And what we have here is a formula. All right. And so the formula is this. We're going to take the absolute value of the new minus the original, put it all over the original. All right. Now, I'm saying absolute value because we're just going to crunch some numbers here. But what we're going to have to do here is a little bit of thinking. All right. Sometimes you might have to do, it might be a decrease and it might be an increase. But the thing is we have the absolute value, we'll always find the percentage, and then we have to apply, if we want it to be a negative percent or a positive percent. So for example, let's say we go from 16 to 12. So I'm going to take my new, I'm going to subtract it by my original, and I'm going to divide it by my original. All right, that's going to give me -4, but it'll be in the absolute value bars, over 16, which is 4 over 16. And so what we saw here was a 25% change. Now, depending on how you do this, like sometimes with certain textbooks or IXL or other platforms, they might say that the actual answer is -25%. Or you might say it is a 25% decrease. So that's why I like to kind of put these absolute value bars, so that way like you get the raw number, and then based on the context you can do what you need to do with it. Now let me clean this up and let's do another example really quickly. Let's say we go from 20 to 24. So I'm going to take my new value, 24 minus 20, surrounded by absolute value bars, divide by my original. This one gives me 4 over 20, which is the same thing as saying 1 over 5th, which becomes a 20% change of percent. All right, and in this case, it is a 20% increase. So again, if we're looking for the raw percentage, just 20, but use some context. This was larger than this one, so therefore it was an increase, whereas in my previous example, it went smaller, so it would be a decrease. So sometimes you'll use the sign to denote that. Other times you actually use the word increase or decrease for it. And so that's how we find our change of percent. Now, let's talk about how to apply it. For that, we have yet another formula. We're going to take the original plus or minus the original times a percent, and that's going to be equal to the new. So for example, let's look at this. A class of 250 students increased by 8%. We need to now find how many students this class has now. So what we'll do is we'll go 250 plus 250 times 0.08. make sure that you convert that percent into an appropriate decimal, and then you'll crunch your numbers. So 250 times 0.08 is 20. Add that to the 250, we end up getting 270 students. That's one way you can do it. Another way you can do this is realizing that we already have a full amount here with the 250, and we could kind of have the 250 factored out and go 1 plus 0.08. So we'll go, like our formula will be the original times 1 plus or minus our percent, and that could also equal the new. And if we do that, we'll get 250 times 1.07. Sorry, 1.08. 1.08. And then we still get 270. Likewise, let's look at this. Something that cost $125 was 40% off. Now notice, I'm using this symbol plus or minus. You have to look at the context to see what's going on. Increased meant plus. 40% off means that we're going to go with a minus. So I have 125 minus 125 times 0.4, 40% off. If I want to, again, I can crunch the numbers like this to get 125 times 0.4, which is 50. So 125 minus 50, which will give me $75. And that's how much you would spend on it. Or again, I could use this other variation of the formula, which is 125 times 1 minus 0.4, which is 0.6, and go 125 times 0.6, and I'll still get $75 either way. But again, the key part here is context clues. Off means I'm decreasing the amount, so I have to use a subtraction sign, not a plus sign. Okay, finally, and I know we're moving quickly here, so there's a lot to process here, but finally, let's take a look at how do we solve with it. We're still going to be using that formula, all right? So the original plus or minus the original times your percent is equal to your new. So let's say a high school class grew by 15%, and now it has 161 students. How many students did it have last year? Well, here's what I'm going to do. I'm going to set up the equation. I don't know what the class size was last year, so that's going to be an x. I still don't know what that original is, so it's x, but I'm timesing it by 15%, which is 0.15. And I'm setting that equal to 161. Now, this is where it gets tricky. I'm going to take my time with this. I have 1x plus 0.015x equals 161. I just kind of tidied up what that looks like. Now, these guys are like terms. 1x and 0.15x can be added up to get 1.15x equals 161. Now I can do 161 divided by 1.15. 161 divided by 1.15, and that's equal to 140. I'm solving for x. I don't know what the original is, so I set up an equation and I solved for it. So I had 140 students last year. Let's do another example. You bought something that was 45% off. If you paid $29.25, how much did it originally cost? All right. Well, same thing. I don't know what it originally cost. I don't know what that original is. So that's x plus x. Oh, no, not plus. Sorry, take that back. Since we're talking about a discount, a sale, minus x times my percentage off, which was 45%, and that equals 29.25. Again, tidying it up, 1x minus 0.45x is equal to 29.25. These are like terms, so 1 minus 0.45 is going to give me, 1 minus 0.45 is, let's see here, one sec, I'm thinking, all right, sorry, 0.55x is equal to 29.25. Now, divide both sides by 0.55, 0.55, so 29.25 divided by 0.55, and I'm getting a weird answer because I realized I set up the problem incorrectly. But in this case, it's going to be 53 $6.18-ish. All right. Sometimes if you go on Amazon, you'll get weird prices for stuff like that. I realized I messed up my percentages when I set up the problem. But anyways, the process is still the same. All right. So we are going to do the subtraction right here. You plug it into the formula and you end up solving for X. So that's change of percent and everything you need to know about it. I get that I went through a lot of it very quickly. So if you need to, rewatch certain segments. And then good luck with your homework or practice, and let me know if you have any questions.